In this presentation we're going to look at reverse percentage change calculations. We're going to look at how it's sort of from a normal percentage change problem and how it could be made into a reverse percentage change problem. A normal problem would look like this, taking 10%, say for example, off the price of something, like in a sale. So this is a straightforward problem which we've probably already done before in another presentation, so it won't take too long to go through how it works. You start off with finding what 10% is. In this case it's £7, then take it away from what you started with to leave you your final price of £63. So that's a normal problem. Now reverse percentage change does the reverse. It's about the problem but going backwards. So a problem would normally look like this. A chair costing £63 after a 10% reduction, and the key word is after. And then the question was, you say, well, how much was it before? So we're going to look at a way in which people often go wrong. We know the answer should be 70. That's what we should know from the previous problem. But the common mistake is to go along a method that looks like this. So the incorrect method would be one where you start off saying, well, if I've got to put 10% back on, well, let's just work out 10% of what we've got and add it on. So 10% of £63 is £6.30. If we add that on to our starting price there of £63 in the problem, we end up with an answer of £69.30. And that doesn't quite get us back to the £70 that we started with. But this is a common mistake that you see people do. So this is something we have to avoid, and we have to look at the problem differently. The correct way you can go about this is one of the correct methods, is to actually say, well, that £63 is actually 90% of what we started with, because we took 10% off. So what we're left with must be worth 90%. And what we want to do then is start saying, well, if we know what 90% is, perhaps we can work it down to 10%. To get from 90% to 10%, we'd want to divide by 9. And if we was to do the same on the other side, we would then actually start to work out what 10% is, and 63 divided by 9 would give us that £7 is worth 10%. From here we can then build it up to get our final answer of 100% being £70. And so this method of, if you like, using the information we've got and a bit of proportion, a bit of sort of figuring out like you might have done before in other kind of problems, is a standard way of getting back to your final answer of £70. But it's not the only way, and there are others that we can use. Now, what if the problem instead was something like this? A TV has 12% taken off, and it now costs £308. How much was it originally? The numbers are not as nice to work with. So this would typically be a problem which is more calculator based than the other problem which could have been done without a calculator. But it's still reverse percentage. The amount has been taken off and we have to get back to what it was before. So the last method we did was called a unitary method. But it wasn't really, but it was close to it. It was about doing the same idea again. Starting off by saying that the £308 is 88% of what we started with. After the 12% is taken off, you've got 88% left. But we can't really get to 10% here. So the unitary method say, well, let's get down to 1%, because we can use a calculator really for this kind of stuff. So here we're looking to divide by 88. If we do the same on the other side, we're going to find out that our 1% value is £3.50. From here we can get to 100%, and we can find that £350 was our starting price. So it's still like the other method. About sort of using this idea of proportion again to get us back to where we started. Now a method that's actually quite, if you like, popular, or at least increasingly popular, is this idea of finding a multiplier. And so the multiplier method is far more efficient, it's far quicker. It's about one line of calculation to get you there, but you do have to think about what you're doing very carefully, because if you do pick the wrong multiplier, you're going to find that you end up with the wrong answer and no way of really checking how you got there. So starting with the £308 that we were given in the problem, the multiplier in this case is more of a divider. Now that sounds a bit weird, this idea of a multiplier, but it's about this one stage calculation. So in this case it's divided by 0.88. Now the 0.88 is easy to think about where it came from. We know that 88% was what we were left with. If we change that to its decimal we get 0.88. Most people would pick to multiply. But the idea is that this is reverse percentage change. So you'd actually have to go in reverse, so it's divide in this case. And if you do this, you'll get straight to your answer. and you don't have to necessarily worry about proportional changes or anything like that. So you can find that the work can be made quicker with this method, but a bit of care has to be taken. So summarising what we've kind of looked at, working out what percentage you have left, that's pretty much key. Figuring out what percentage you've got, this could be as a result of an increase or decrease. Divide it to get to 10% or 1%. Depending as to the numbers you got, you might even actually figure other numbers like 20%, 25%, depends what you're working with. But 10% and 1% are quite common to get to. Multiply up to get to 100, so that you actually get back to that original point. The same method applies when there's been a percentage increase. The only thing here is that if you was to do that, you would end up with, say, 120% or 110% at the start, and then, you know, when you divide, you're dividing by an amount which may seem a bit more awkward. It depends on the numbers again as to whether it's a calculator or non-calculator, but usually you know, the numbers in the problem would be appropriate for whatever paper you're doing. And the final idea is this idea of multipliers, that they can speed up the task, they can make things go quicker, but picking it carefully. And in the case of reverse percentages, these multipliers are really dividers, okay, something you're dividing by. Hopefully that's been useful just as a quick recap on how to do reverse percentage change problems.